Alright, so this equation, this graph pulls out basically all the stops. It's going to be crazy, right? So we're going to look at it, we're going to see it's a cosine function. I got a multiplier in front of the x, something's added onto the x. This one's going to shift the graph up, this negative one's going to stretch it and make it shrink between different values. And this is not going to look like any of the other graphs we've done so far, really. I mean, it's still going to squiggle up and down, don't get me wrong, but none of the x values and things are going to match. What we have to start with is, where does this graph begin and end its typical period? So our first job is to find out what these new x values are, where we're going to have our x-intercepts and our local maxes and our local mins. And this is going to scrunch it up, and this is going to shift it over, and basically I'm going to need to take this expression right here and figure out what can I plug in for x to make it negative 2 pi, what do I plug in for x to make it equal 0, and what do I plug in for x to make it positive 2 pi. So I get those two full periods. And that's going to be some fun algebra. What I'm going to do is I'll do the tougher of the three on video and explain it, and then you guys will try to do the other two kind of on your own. But I want to know, when does this equal negative 2 pi? That's my goal. And there's fractions here, so let me go ahead and not think of this so much as 2 pi, but more, this is pi over 4. I'm going to have to add that over there. So I'm going to think of this as negative 8 pi over 4. When I add a pi over 4, I hope everyone else is doing this. Since now they're both pi over 4, I'm really just doing negative 8 plus 1 in my head. And then I'll tack on the pi and I'll tack on the 4. So if I add a pi over 4 and I add a pi over 4, then this side just has a 3x left. In my head, I'm just doing negative 8 plus 1. Which is negative 7. So it's negative 7 pi over 4. That x is not by itself yet, so I'm not going to divide by 3 as much as multiply by a third, because that's just a better option if I've got fractions involved here. And that means the x value that makes me hit that negative 2 over pi is going to be whatever this is. And if you don't remember how to multiply fractions, top by top, bottom by bottom. Negative 7 pi over 12. So we're going to do this similar thing, setting this equal to 0 and equal to 2 pi. This is the hardest part. And I'm going to pause and do all my work, and you are hopefully going to try to do the work as well. But I'm not going to explain the work, so you're going to be better off pausing the video at this moment and trying it while I show the work to this part. So these are the answers that I did come up with. I do want to point out that, I'm multiplying by 1/3. And over here, you might be thinking to yourself, Mr. Dupsick, we could totally reduce that fraction. But if you've watched other videos about how to find midpoints, we usually want to have common denominators anyway. And so I'm not going to reduce the fraction. I'm going to leave it just the way it is. Because now we're on to phase 2. So what's happening, just to be clear, is we know that there's two periods that are happening here. One of the periods goes from what was negative 2 pi to what was 0. And the other period's going from what was 0 to what is 2 pi. And I want to break both of these in half. So I'm about to delete all of this work. Now, of course, you can rewind it. But in the next second, it's going to all be gone. And we'll just look at these endpoints. And we're going to see how to make sure that we can get them each broken into 4 equal pieces. And that's what you're going to see is right now. These are the values that I cared about, and now that we have all common denominators, now that we all have pi's everywhere, I just need to worry about these coefficients of negative 7, 1, and 9. And it's the same trick. If I want to know what's halfway between 1 and 9, I'll take the average. That's going to be 5. 9 plus 1 is 10, divided by 2 is 5. To find the halfway point of this halfway point, I'll find the average. I'll find the average, and then I'm going to know it's going to be pi over 12, 5 pi over 12, 3 pi over 12, 7 pi over 12. Likewise over here, why don't you pause your video and see if you can't get the correct values, and you'll see them there. I'm going to pause, it's just going to appear. And if you're not sure how I'm getting them, I'm going to take the average of these two endpoints, the negative 7 and the 1. And I'm going to get that number, and then I'm going to find the average of these and the average of those. Let me show you what I mean. So those other midpoints would be -3, and then the midpoint of that between 1 is -1, and then -5. But I just, like I said, I found this one first by finding out this average. That's the midway point. Once I knew that -3, I could easily find these by finding the average of these to get the -5, and then the average of this and this to get -1. I'm showing the calculations up here. And now I'll tack back on all that extra stuff. So this is really -3 pi over 12. This is really -pi over 12. This is really -5 pi over 12. So all of these values here are what became of all of these x values up here, that they all moved over. When I put them on the x-axis, I am going to reduce the functions. So I'm going to, again, erase all the work that I have here. You're going to see me transfer all these numbers to the x-axis. Once we have that part done, figuring out how to put this into the function and this into the function is not nearly as bad. This is all the heavy lifting. So pausing the video to draw in this function. Here we go. This is my chicken scratch for all these numbers. You'll notice I did things like 9 pi over 12. I wrote that as 3 pi over 4. 3 pi over 12, I wrote that as pi over 4. A couple things I can't emphasize enough. If you think back to those equations that we started with, this is where we took the cosine of 0. So this was 0, this was 2 pi, this was -2 pi. So when we graph this, we'll have to refer to what the cosine function does with those values to help us out. But we got our good x values down. Now what else happened? Well, this +1 is going to take what's normally that 0 line, and by 0 line I mean the place where the function crosses the x-axis, and shift it up 1 full unit. So I'll go up here and I'm going to draw a nice beautiful guideline at the value y equals 1. And then the stretch factor, this 1/2, means I'm not going to go 1 above and 1 below and 1 above and 1 below. All those y values got reduced by that multiplier of 1/2. So it's just going to go 1/2 above and 1/2 below and 1/2 above and 1/2 below. So I'm going to draw in a couple other guiding lines. Let's say this is the value 2 and that's the value 0. Well, above this guiding line, it'll just be 1/2 above. If cosine goes a full unit above and I have a 1/2, it'll be just 1/2. So I'm going to put another guiding line in here. The function is never going to get higher than 1/2, and it's never going to get lower than 1/2 below. So my function will live between these two values. Now the final piece, this negative, means that whatever cosine was doing, if it's going to go up because of negative, it'll go down. And if it was going to be down because of the negative, now it's going to be up. So even though cosine, when cosine's at 0, we usually go up 1 like this. First of all, 0 moved to pi over 12. So I'm going to be here. And I would normally go up to the high point, but since it's negative, I'll go down. So I'll go down. And then at the next point, we'll be at the 0 line. And then we'll be 1 above it. And then we'll be back to the 0 line. And then we'll be 1 below it. And from that point, we're going to be, the next point's not the axis, which is unusual. The next point's negative pi over 12. So from here, I'll go up to the 0 line. I'll go up here, and then down here. And I'll try my best to draw in a beautiful function. Can it get any more nasty? Not at all. Now, here's a fun question that I'll address in the next video. Supposing that it was everything about this function was the same, except instead of saying cosine, I had said sine. How is that going to change what we do? I'll address that in a video that I hope is far less than 9 minutes and 17 seconds.